Okay, this is unit number 3, video 3 on electron configuration. So now that we've learned kind of where we can find the electrons using quantum numbers, we can kind of shorten all that down and use something we call electron configuration to kind of represent where we find all of the electrons. So the way we're going to do this is we're going to use the periodic table. Periodic table is arranged perfectly for finding or for writing the electron configuration. It's a very methodical way to do it. Now the key here is when we're looking at all of these are the ground states. So this is the electron configuration we're writing is the lowest level of energy for the electron configuration that we can write for these atoms. So the periodic table is broken up into our L quantum numbers. So our L quantum numbers are the S, the P, the D, and the F. So the 0, the 1, the 2, and the 3. So here on the left side of the periodic table, we're going to find our S column. And if you look at the S column, in the S column right here, we have 2 electrons because we know each orbital can hold 2 electrons. And for the S, there is only 1 orbital. So therefore, the maximum amount of electrons we can have in each of these is 2. Then from 3 to 12, so these right here, I'm gonna bring these in just a minute, but we're gonna go over here. This is gonna represent our D. So this is gonna be our 2. D is gonna represent 2 for the L. And we're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in our D because our D is gonna have 5 orbitals. So if the D has 5 orbitals, we know each electron can hold, or each orbital holds 2 electrons, so the maximum amount of electrons we can have is 10. So that's why the D is represented by 10. Now if we go over here, dealing over here from 13 to 18, and helium for electron configuration we're going to assume is over here, so we're going to pop the helium over there. So the P block over here is going to be represented by 6 electrons. So we have 1, 2, 3, 4, 5, 6. We know each electron can hold, or each orbital can hold 2 electrons, so we're going to have 3 orbitals. So if we've got a maximum of 6, 6 divided by 2, so if you always divide by 2, it'll give you how many orbitals you have for each column. Now if you go down here, there's 2 little stars right here. These are going to represent our F block. Our F block has 14, if you go through and count it, there's 14 electrons in our F block. So 14 divided by 2, we're going to get 7 orbitals for our F block. Now the way we're going to read electron configuration is we're going to read it just like a book. So we're going to read it left to right, and then you're going to come down a row. Now the way we do the energy levels, our principal quantum numbers, is the rows. So they're all labeled for you. So this is going to be 1. We call these periods as we go across. So this is going to be our principal quantum number 1, 2, 3, 4, 5, 6, and 7. Now the only part where we're going to vary is when we come into the 4. So at this point, we're going to be in the 4s, and this would be 4s2 if we went to calcium. Now when we start the D block, the D is always going to be 1 less. So it's never going to start with 4, it's always going to start with 3. Now the same thing is going to happen when you come down here to the F block. So here we're in the 6s. Now this is going to be 2 less for the F block. So we're not going to do D is 1 less, F is 2 less. So instead of starting with 6 or 5F, we're going to start with 4F. So 4F and 5F is all we have. So if we were to do an example for that, let's do the electron configuration for, let's do sulfur. So if we look at sulfur, the first thing we need to do is figure out how many electrons it has. Sulfur has 16 electrons. So I need to make sure I have 16 electrons in total when I write my electron configuration. So we're always going to start at the top. So we're going to start at the hydrogen. We are in the first energy level, and we're going to fill until we reach sulfur. So in the hydrogen, you're going to pretend helium's over there. We fill both of those, so it's going to be the 1s. We're going to have 2 electrons in here. Okay, now our superscript is going to tell us how many electrons are in the orbital. Now, once we filled here, we've come down to this block here. So we're in the 2s column now. So we're going to write 2s, and we filled both of those, so 2s2. Now we're going to come over directly to boron. Boron is still in the 2nd row, so we're going to be in the 2 column, or the 2 row, but now we're in our P block. So this is the 2p. We fill all of those, because remember we need to get to sulfur. So we fill all of those, so that's going to be 6. And if you forget how many to fill, just count over until you've filled the P block. Now we're going to jump down to the 3rd energy level. So we're going to jump down to sodium. Sodium, we're in the 3s column. We fill both of those. There's only 2 electrons there, so 3s2. Now we're going to come right over to aluminum. Aluminum is still in the 3rd energy level, but now we're no longer in the S sub-energy level. We are now in the P. So we're in the 3p, and we're going to count until we get to sulfur. So this is 1, 2, 3, 4. So 3p4 is the electron configuration for sulfur. Okay, now if we look at one that is maybe in the D block. So let's start down here and let's do the electron configuration for chromium. Okay, so chromium, we're going to start at the very beginning again. So it's always start from the top and read till you get to chromium. So we fill until we get to it. So 1s2, we're at the helium. We're going to drop down to lithium. We're in the 2s. We fill both of those, so 2s2. We come over to boron. We're still in the 2p column. We fill all of those, so that's 6 electrons. Then we jump down to sodium, so we're in the 3s. Now we fill both of those, so 3s2. Now we're over at aluminum. Aluminum is still in the 3rd column, or I'm sorry, the 3rd row. So it's 3p. We fill all of those, so we're 3p6. Then we're going to jump down to potassium. Potassium is now the 4s. We're going to fill both of those till we get to calcium. Now, at scandium, we've hit the D block, so we're always 1 less for scandium. We're right here between 20 and 21. So this is the 4s because we're in the 4th row, but for D, we're always 1 less. So this is going to be the 3D. And we're going to count until we get to chromium. So 1, 2, 3, 4. So the 3D4. Now, as chemists, we don't really write, this is called the full electron configuration. We use abbreviated configurations. So we're going to use noble gases to abbreviate the electron configuration. So the way we're going to do that is we're going to use our noble gases. So if we were to look at chromium, noble gas that comes before chromium is argon. So in parentheses, or not parentheses, in brackets, we're going to write argon. And then we're going to do the electron configuration starting after argon. So if you jump down from argon, we're in potassium, so this is the 4s2. And then we're going to do the ending till we get to chromium, so it is 3d4. Okay, so all this has done is it's cut off the ending here, so we've kind of, argon has covered this main group right here, and we're dealing with our valence electrons, which is going to give us our shorthand notation for electron configuration.